Hi everyone, welcome to the first chapter of statistics. I hope you are excited. Statistics is unlike any other math class we've had before. It's almost a completely different subject. Learning a new subject is like learning a new language, a new way of thinking. So in order to understand each other, we have to learn a whole new set of definitions. So the first few lectures will be heavy on definitions and terms. Okay, so let's start. Statistics plays a major role in many aspects of our lives, right? So for example, it is used in sports to help a general manager decide which player might be the best fit for a team. Also, it is used in politics to help candidates understand how the public feels about different policies. And also, it is used in medicine to help determine the effectiveness of new drugs. So, if used appropriately, statistics can be really useful and it enhances our understanding of the world around us. But if it is used inappropriately, it can lead to support inaccurate beliefs. Studying statistics and understanding statistical methods will provide you with the ability to analyze and critique studies and the opportunity to become an informed consumer of information. Okay, so the first term you're going to learn is, drum roll please, statistics. Of course, right? Here we go. Statistics is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusion. Now, what is the information referred to in the definition? The information is data. Okay, data can be numerical or non-numerical. Either way, data describe characteristics of an individual. Now, a key aspect of data is that they vary. Here's the major difference between mathematics and statistics. In mathematics, when a problem is solved correctly, the results can be reported with 100% certainty. But in statistics, when a problem is solved, meaning data are collected and analyzed, the results do not have 100% certainty because data vary. Look around. Is everyone the same height? No. Does everyone have the same hair color? No. So within groups, there is variation. Now think about yourself. Do you eat the same amount of food each day? No. Do you sleep exactly the same amount of hours each day? No. So even considering an individual, there is variation. Because data vary, two different statistical analysis of the same variable can lead to different results, right? So because statistical studies draw on samples, and because there is variation within groups, results cannot be reported with a 100% certainty. So this last part right here, statistics is about providing a measure of confidence in any conclusion. This part is very important because results cannot be reported with 100% certainty. We need to include a level of confidence to measure the reliability of the results. Any statistical results should be reported using some measure that represents how convinced we are that our conclusions reflect reality. Now, we're going to look at an example that walks us through the process of statistics. Okay, so it says, a news service conducted a survey of 1,086 adults ages 18 years or older in a certain country, August 31st to September 2nd, 2018. The respondents were asked, of every tax dollar that goes to the federal government, how many cents of each dollar would you say are wasted? The four possible responses are that the federal government wastes less than 10 cents, between 11 cents and 25 cents, between 26 cents and 50 cents, or 51 cents or more. Of the 1,086 individuals surveyed, 38% indicated that 51 cents or more is wasted. The news service reported that 38% of adults in the country 18 years or older believe the federal government wastes at least 51 cents of each dollar spent, with a margin of error of 4% and a 95% level of confidence. Okay, so here's an important vocabulary word, population. So the population is the entire group of individuals to be studied. What is the population in this example? Okay, so the population for this example will be the whole entire adults in the country aged 18 years or older. So right here, adults aged 18 years or older. Okay, now not the 1,086 right here, 1,086 adults that are surveyed, they're not the population. That is called a sample, right? Actually, this is a common mistake that students make. A population must be the entire group of individuals in the study. It does not necessarily mean that we survey all of them, because that will be too much. But what would be the complete collection of individuals in the study if we have a time and money to study all of them? That will be all adults in the country aged 18 years or older, right? So that will be our population. Okay, so let's write that down. Adults, you can put all adults, but adults will be fine. Adults in the country aged 18 years or older. Okay, next. An individual is a person or object that is a member of the population being studied. What is an individual in this example? Okay, so that will be just one adult in the country aged 18 years or older. That's it. So just one adult in the country aged 18 years or older. Okay. Okay, now a sample is a subset of the population being studied. What is the sample in this example? All right, so that will be the 1,086 adults in the country that were surveyed. Okay, so they are the sample. So the 1,086 adults in the country that were surveyed. All right, so after we've gathered our sample and given our survey, we get some results back, right? And that is, let's see, what is the result we got? So it says here that of the 1,086 individuals surveyed, that's our sample, right? 38% indicated that 51 cents or more is wasted, okay? So that's what we found out from our sample. So the process of getting some results from a sample is called descriptive statistics, okay? And the descriptive statistics consists of organizing and summarizing data. And descriptive statistics describes the data through numerical summaries, tables, and graphs, right? So let's write that down. We found out that the 38% of the individuals surveyed indicated that 51 cents or more is wasted. Okay, so that's what we found out, right? And that's the result we got from our sample. Okay, now a statistic is a numerical summary based on a sample. So that will be 38%. So just this number itself, 38%. So this is a statistic because it is a numerical summary. It's a number, right? Based on a sample of 1,086 adults. Okay? Okay, so riddle me this. What would it look like if we take the descriptive statistic in the previous page and apply it to the entire population, right? So we're not allowed to say that 38% of all adults in the country aged 18 years or older believe that the federal government wastes at least 51 cents of each dollar spent. Because if we took a different sample of different adults and asked the same question, right, we were probably going to get a different result. Okay, not exactly 38%. So we have to keep that in mind when we start talking about the entire population. In the process of taking information from a small sample, right, so small group, and apply it to the entire population is called inferential statistics. Okay, so that is our next definition. Inferential statistics uses methods that take results from a sample, extends them to the population, and measures the reliability of the result. So what can be inferred from this survey, right? So we have that 38% from the previous page, right? So that's the statistic. Okay, so this is the statistic, the result from the sample of 1,086 people. Okay, so when we extend this result to the entire population, we know that if we take a different sample, we're going to get a different proportion. But if it's a good sample that represents the population, then the numbers should be approximately the same. And the number might not be perfect, but it's close to the actual number. So what we do when we extend the result to the population is we add some wiggle room. And that wiggle room is called a margin of error. Now, in this example, it says that the news service reported that 38% of all adults in the country 18 years or older believe the federal government wastes at least 51 cents of each dollar spent with a margin of error of 4% and a 95% level of confidence. So, okay, we have that 38%, which is a sample statistic, and we add and subtract 4 percentage points, which is the margin of error. So plus or minus 4%. So this is the margin of error. So this is the wiggle room. Okay, so we have the lower limit of 34%. So 38% minus 4%, right? That will be 34%. Okay, that will be lower limit. And the upper limit will be 38% plus 4%. That will be 42%, right? Okay, so we have an interval of two numbers, 34% to 42%. Okay, so that is us extending them to the population. We have to add wiggle room, right? And depending on how big our wiggle room is, if we have a large amount of wiggle room, then we're going to be more confident. And if we have a small amount of wiggle room, then we're going to be less confident. And we're going to calculate all of this later in the confidence interval chapter. Now for this one, they're telling you that the level of confidence is 95%. So this 95% confidence measures the reliability of the results. Okay, the generalization contains uncertainty because a sample cannot tell us everything about a population. So inferential statistics needs to include a level of confidence in the results. All right, so let's write out the answer to the question, what can be inferred from this survey? Okay, so we can say something like, the news service is 95% confident that the percentage of all adults in the country who believe the federal government wastes at least 51 cents of every dollar spent is between 34% and 42%. There you go. All right. So one goal of inferential statistics is to use statistics, sample statistics, to estimate parameters. And that's our next definition. A parameter is a numerical summary of a population. Remember, a statistic is a numerical summary of a sample, right? A parameter is a numerical summary of a population. You know, actually, there's a kind of nice way to memorize this. Statistic is from a sample, right? They both start with letter S, right? And the parameter is from a population, right? Look, they both start with P. Kind of nice, right? Okay, so again, a parameter is a numerical summary of a population, okay? So that would be the true percentage of all adults in the country who believe that the federal government wastes at least 51 cents of every dollar spent, which we're not going to be able to find that out because in order to do that, you have to survey every single adult in the country who is 18 years or older, which is very difficult to do, actually impossible to do, okay? So we usually use statistics to estimate parameters. And for our example, our parameter that we're estimating is the percentage of all adults in the country who believe that the federal government wastes at least 51 cents of every dollar spent. Okay, so let's do a quick example. Parameter or statistic. Number one, in a survey of a sample of 12,000 adults in a certain city, 12% said they left for work before 6 a.m. Okay, so this underlined number, 12%, is this a parameter or is this a statistic, right? So the answer is, it is a statistic. Why? Because 12% is based on a sample of 12,000 adults. It says a sample, right? So this number 12% is a numerical summary of a sample, right? So that's why. Okay, so 12% is based on a sample of 12,000 adults. Okay, so that's why it's statistic. Okay, it's a statistic. Let me highlight that. There we go. All right. Okay, number 2. Following the election, 18% of the governors of all 50 areas of a country were female. Okay, so this number 18%, is this a statistic or parameter? This is a parameter. Why? Let me highlight that first. Okay, I like to highlight things that are important, of course. Okay, because this 18% is a numerical summary of a population. How do we know it's a population? It says all 50 areas of a country. So that represents the entire population, right? So 18% is based on a population of governors in the country. Okay, there we go. Okay, so let's go over the process of statistics. This process walks us through our semester. Okay, so first we identify the research objective. Okay, so that's number 1. Identify the research objective. So a researcher must determine the questions he or she wants answered and identify the population that is to be studied. Okay, so for the example we just did, the research objective would be to determine the percentage of adults in the country who believe that the federal government wastes at least 51 cents of every dollar spent, right? All right, now step 2 is to collect data through sample. Okay. Through sample. All right, so we typically look at a sample since conducting research on an entire population is really difficult and it costs money, right? Okay, so that's number 2. Then we describe data using descriptive statistics. So descriptive statistics allow the researcher to obtain an overview of the data and can help determine the type of statistical methods that the researcher should use. And finally, we perform inference. So we're going to apply the appropriate techniques to extend the results from a sample to the population and report a level of reliability of the results. So this is a nice visual of what we just talked about. Population is what we want to study, but since we usually do not have access to the entire population, we work with a randomly selected sample, right? So this is much easier to work with. And from our sample, we get a statistic. We calculate a statistic. And then we do our inferential statistics to estimate a parameter. And we call that inference, right? Okay, so we kind of have this cycle, right? And don't worry about these symbols, x bar and mu on the bottom. We will cover them in a later chapter, okay? So that's it for this video. We're going to finish this section in the next video. All right, so see you in the next one. Bye guys.